In this video, we will learn about the chain of responsibility design pattern and how to implement it using C++ code. Chain of responsibility is the first of many behavioral design patterns we will learn about in this section of the course. Behavioral design patterns deal with how objects in our program communicate with one another and how the program assigns responsibilities to these objects. The chain of responsibility design pattern allows us to pass requests along a chain of handlers. When one of the handlers receives the request, it determines if it can handle that request, and if not, it passes it to the next handler in the chain. A real-world example of this is a factory assembly line. Each worker has one task in that line. As the product is passed down the chain, the worker responsible for the task performs an action. If another task needs to be performed on the object, it gets passed to the next worker in the assembly line. Let's learn how to implement the chain of responsibility design pattern using C++ code. Up at the top of the code, we will include the vector header file. Next, we will create a class named handler. We will create a virtual method with a return type of handler named setNext that takes in one parameter, a pointer to a handler named handler. Then we will create a virtual function that returns a string named handle, which takes in one parameter, an int named request. After that, we will create a class named abstractHandler that extends the handler class with public accessibility. Inside of this function, we will have a pointer to a handler named nextHandler. Then we will use the public access modifier. We will define a constructor for our abstractHandler class that initializes nextHandler to a null pointer. Then we will override the base class's setNext function. Inside of this function, we will set nextHandler equal to handler. Then we will return handler. After that, we will override the base class's handle function. Inside of here, we will check if nextHandler is not null, and if so, we will return a call to the nextHandler's handle function with a request passed in. At the bottom of the function, we will return an empty string in case the other return statement was not hit. Next up, we will create a class named handler1 that extends the abstractHandler class with a public accessibility. Inside of this function, we will use the public access modifier and override the base class's handle function. Inside of this function, we will check if request is equal to 1. If so, we will return the string tab and then handler1 handling the request. Else, we will return a call to the abstractHandler class's handle function so that the request gets passed off to the next handler. Then we will create a class named handler2 that extends the abstractHandler class with a public accessibility. Inside of this class, we will use the public access modifier and override the base class's handle function. Inside of this function, we will check if request equals 2. If so, we will return a tab and then the string handler2 handling the request. Else, we will return a call to the base class's handle function so that the request gets passed along to the next handler in the chain. After that, we will create a class named handler3 that extends the abstractHandler class with public accessibility. Inside of this class, we will use the public access modifier and override the base class's handle function. Inside of this function, we will check if request equals 3. If so, we will return the string tab and then handler3 handling the request. Else, we will return a call to the base class's handle method so that the request gets passed to the next handler in the chain. Next, we will create a function with a void return type named clientCode that takes in one parameter of type handler named handler, being sure to add the ampersand in front of the name. Inside of this function, we will have a vector of integers named requests with the values 1, 2, 3, and 4. Next, we will use a for loop that iterates over each constant int request in our requests vector. Inside of this for loop, we will output a new line, and then the string client requesting, then the request, and then another new line to the console. After that, we will have a constant string variable named result that we set equal to a call to handler's handle function with request passed in. If the result is not empty, we will output a space, and then the value of result. Else, we will output a tab, then the request, and then a message that it was left unhandled, since this part of the code will get hit if none of the handlers were able to handle the request. Time to test our code. Inside of C++'s main function, we will have a pointer to a handler1 object named handler1. that we set to a new handler1. We will also have a pointer to a handler2 object named handler2, set to a new handler2, and a pointer to a handler3 object named handler3, set to a new handler3. Then we will call handler1's setNext function and pass in handler2, and then call its setNext function and pass in handler3. This creates our chain of handlers 1, then 2, and then 3. Let's make a call to the client code function and pass in our handler1 pointer. Finally, we will delete handler1, handler2, and handler3 respectively. Before we run the code, I just want to make a few adjustments. First, let's make the two virtual functions inside of our handler class public. Then we will scroll down to our client code function. Since in some older versions of C++ you may get an error if you run the code like this, I want to change it so that it works for anyone watching. Let's change the initialization of our requests vector so that each element is added individually using the pushback function. When we run the code, notice that handler1 handled request 1, handler2 handled request 2, handler3 handled request 3, and request 4 was left unhandled, since none of the handlers in our code are able to handle a request with a value of 4. The chain of responsibility pattern is best used when our program should be able to process different types of requests, but the types and order of requests are not known beforehand. Advantages of this design pattern are that we can control the order in which requests are handled, it follows the single responsibility principle, and we can introduce new handlers into the program without breaking the existing code. The disadvantage of this pattern is that some of the requests may end up unhandled.